In this video, we're going to solve the enthalpy problem that says how much energy is generated when 1 gram of hydrogen peroxide is decomposed. And here's the balanced equation that 2 hydrogen peroxides yield 2 waters and 2 oxygens, and the enthalpy for that reaction is negative 196.4 kilojoules. And that means that when we have this balanced equation, this is how much energy we get. So for every 2 moles of hydrogen peroxide that decomposes, we get this much energy. For every 2 moles of water produced, we get this much energy. For every 1 mole of oxygen produced, we get this much energy. So we can use that mole relationship then to go about solving for how much energy is generated if we have only 1 gram of hydrogen peroxide. So we're going to start this like any other stoichiometry problem. We have a written and balanced equation here. And we're going to take the given 1 gram of H2O2 and we're going to change that to moles. So 1 mole goes in this position because we're changing it, and we add up H2O2. Oxygen is 16 times 2 is 32. Hydrogen is essentially 1. So let's just call this 34.0 grams of H2O2. So 1 gram times 1 mole over 34 grams. The grams are going to cancel out here, and we're going to end up with 0.0294 moles of H2O2. Again, I'd urge you to stop, pause here, and put that in your calculator to make sure you get the same thing I do. And then once we have that changed to moles, so our original step was to balance the equation, and that's done. Now we change what we're given to moles. Now we're going to use the mole ratio, but for an enthalpy problem, the mole ratio is a little simpler. We're going to take the thing we just got, 0.94 moles of H2O2. Okay, now here's the thing. When we normally do a mole ratio, we put what we are coming from and put it on the bottom, and that's H2O2. So we're going to go up here, and we're going to find this 2 in front, and that goes down here. But here's the thing about this. We don't put a mole up on top, even though this is a mole ratio. From the balanced equation, we know that when we have 2 moles of H2O2, we get this much energy. So we're going to put that up there. And that's in kilojoules. So now, moles of H2O2 will cancel out moles of H2O2. We end up in just kilojoules. And so when we take that answer from before times negative 196.4 and divided by 2, we get 2.89 kilojoules. Again, pause, put it in the calculator to make sure that's what you get. But that seems reasonable. If the entire reaction gives us a negative 196 and we have a small amount, only 1 gram, we would expect to get only a small amount of energy. So there you go. That is a thermochemistry enthalpy problem.